Alright, so now let's begin with the final question of this paper. It's given that the diagram shows a smooth track. Smooth track means there is no friction throughout this whole track and it lies in a vertical plane. The section AB is a quarter circle of radius 1.8 meters with a center at point O. The section BC is a straight horizontal line or a horizontal straight line of length 7 meters. Then this OB is acting perpendicular to this particular BC track. And then the section CFE is again a straight line, but now inclined at an angle of theta degrees above this particular horizontal line. So that's the information that we have decoded from the first paragraph. And always trust the power of imagining. How can you draw this kind of diagram by yourself, even if this was not given? If you are able to do that, trust me, guys, your 80%, or I should say 75% of the whole question is solved right over there. The remaining part depends on how much good amount of practice you are having of these concepts. And trust me, mechanics is very simple to master. If you are just watching my videos of previous 5 years of mechanics one, trust me, you are going to get at least minimum of somewhere about high B grade or even an A grade if you are able to follow everything that I explained. You don't need to learn anything from beginning. You just watch my videos of these papers because I also explain the concepts from scratch before we implement it onto this kind of questions. So if you're following it for previous 5 papers, scoring an A grade is not that difficult. And we are also providing a free doubt tool on WhatsApp. You can join that. The link is provided in the description. Uh, just in case if you're having some kind of difficulties in understanding why I did a particular thing, what other ideas that you are having to solve that, if it's correct or not. If you want to do these kind of discussions, you are free. You are most welcome on that free tool of doubt solving. And I, along with me, there are different students who have scored world rank and even multiple teachers are over there. We all will be there to guide you over there. Okay, so reach out to us with the help of that WhatsApp group. But yes, make sure mechanics is not a big deal. If you are facing difficulties, reach out to us and we'll help you. We'll literally help you go to A grade, at least for this paper, right? Because it's an easy scoring paper. All right. But anyway, coming to the second paragraph, this paragraph says that a particle P of mass 0.5 kg is released from rest at point A. So from point A, let's draw a particle P. It's released from rest. And I'll also highlight this that P is having a mass of 0.5 kg. Now this particle P is colliding. So there is some kind of conservation of momentum going to be involved. See, how do I know this? Because I know there is a kind of a collision involved. And in the whole mechanics, where does the collision come into the picture? Only in the conservation of momentum kind of questions. So let's see how we can use this kind of concept for this question. So particle P is colliding with particle Q and Q is having a mass of 0.1 kg. It's resting at B. So basically over here, we are also having particle Q. Now, immediately after the collision, the speed of P is 4 centimeters, not centimeters, meter per second. And then it's moving in the direction of BC. So after the collision, obviously Q will go in the right hand side, but Q is also going to go in the right hand side. It's not going to go back. It's not going to stay as it is. It's going to move with the speed of 4 meter per second in that same direction from B to C. Now, you should assume that P is moving horizontally when it collides with Q. And in the first part, it's asked us to show that the speed of Q immediately after the collision is occurred, the Q is going to move with the speed of 10 meter per second on this track. And now this line is really very important. The one at the end. You should assume that P is moving horizontally when it collides with Q. So the kind of situation that they're trying us to imagine before the collision is something like this. Let's say that this is a kind of a curved track ending somewhere over here. Then your particle Q is over here. Particles are like pretty much small, something like this. Let's say this is Q. And then P is coming from back. So it's now on the horizontal track itself. That's what you have to assume. Now, just before the collision, we don't know what is the speed of P. Let's call it Vp. And Q is at rest. I know that. And after the collision is done, if I draw something after somewhere on right, let's say Q is now over here, started moving towards right, and that's the speed that we are trying to find, Vq. And P is going to have speed of 4 meter per second. That is what is given to us in the question. right? So this is before or initial conditions, and these are the after conditions. I can just break this into half. It's not a continuation, okay? It's initial conditions before the collision, and these are the conditions after the collision. Now, this is something that we'll be using to find out what is the velocity of Q. But before that, we have to figure out what's the velocity of P before it just intersects or collides with Q. So now for that, we are going to use the concept of work energy theorem. Whenever you are having this kind of diagrams, you will see that automatically this kind of intuition will come to use work energy theorem. And that theorem states that the change in work, now this work is done with respect to some artificial forces, like let's say some kind of paddling, some kind of engine, something which is not natural because of gravity. All that force is what we are going to keep with respect to the work done, okay? Because we know that work done is nothing but the force into the direction on which that force is being applied. So that's what work done is. So now, because there is no external force over here, and there is also no resistive forces that will give us the work due to backward side, this delta W is zero. But now that delta W is equal to the change in kinetic energy plus change in potential energy. So now over here, I explained you why the delta W value is zero, because there is no external force which is driving it ahead. It's because of gravity that it's falling downwards. And there's again no resistive force. So basically there is no work done because of the friction or something like that. So the change in work done is basically zero. And now if you talk about the kinetic energy, it's half times mass of particle P is 0.5 times the final speed square minus the initial speed square. So for part P, the final speed is something that we are trying to find, that's Vp square. And initial speed, because we are starting it from rest, the particle P is released from rest at A. So initial speed is zero. Now you add the change of potential energy. We know that the formula is mgh. So m, g, and h, final height minus initial height. Final height is at, basically, let's assume that this is a reference point and let's consider it as a ground as at height 0. So final height is 0 minus initial height from A. This height is given to us as 1.8 meters, as you can see. So 0 minus 1.8. So this becomes your final equation for this work energy theorem. And if you will solve this equation, the answer that you will be getting for Vp once you solve this is going to come out as 6 meter per second. So that's the speed that we are having just before the collision over here. Now, once we are having these initial conditions and the final conditions, we can go ahead and implement the conservation of momentum to find the speed of particle Q after the collision. So what is the formula that we have for the conservation of momentum? We know that initial momentum before the collision is equal to the condition after the collision. So initial momentum equals to the final momentum. And the formula of momentum is mass of that body into what is the velocity with which it's moving. That gives your momentum of the body. So now for the initial conditions, the mass of P is 0.5 and the speed at which it's moving is 6. That's what we figured out just a second ago. And after that, for Q, mass is 0.1 kgs, but now there is no speed. Initially it was at rest. After the collision is done, the mass remains same, right? 0.5 for P, and now it's moving with the velocity of 4 meter per second. For Q, mass is 0.1, and the speed, let's say it's Vq, right? That's speed that we are trying to figure out. Now, if you will solve this in your calc, you must get the value of Vq as 10 meter per second. So now that's the answer that you are going to get for the first part. That's what we had to prove. And now let's go ahead and look into the part B of this question. So for that, I'll also get rid of this unnecessary informations. We'll use them as per requirement of this part B. So when Q reaches the point C, what I'll do is I'll just scroll a bit upwards so that we are having enough space to draw something if we have to. Okay, and let me also create this kind of extra box of white color to hide that 11. Okay. So now When Q reaches point C, remember that B was over here and the collision has happened. Q is moving with the speed of 10 meter per second. Over here, it's C. And that distance was given to us as 0.7, 7 meters, 7.0 meters. So when Q reaches the point C, after that, the inclined plane is starting, right? If you remember, CFE. So that's the plane. And over here, that's the theta. And now it's given that it collides with a particle R at point C. So now there is also a particle lying at C. So that is particle R. And Q is approaching that particle from the backside. What's the velocity at which it's moving? Because this is a smooth surface, the speed will remain constant because it does not have any kind of backward force to slow it down. It does not have any kind of force to increase the speed. And therefore, because after the collision, the speed of Q is 10, throughout this whole BC track, the speed will remain 10 meter per second. That's the initial conditions of Q. Now, two particles collides. Collides basically means when Q and R mixed together, are mixed together basically. All right. So the combined particle, as they have mentioned, the combined particles comes instantaneously to the rest at point F. Let's say there is a point F over here. So after the collision, we know that it's a combined particle R plus Q, right? R plus Q. And over here, the speed is basically zero. It's coming to the rest, instantaneous rest. You should assume that there is no instantaneous change in speed as the combined particles leave C, nor when it passes through the sea, again as it returns down the slope. So we know that once the velocity is zero, once it reaches at the maximum height, obviously it will roll down because there is no friction to stop it. So because the speed is over, it cannot travel further upwards. And because of the slope, because of the gravity, it's going to be pulled in that particular direction. Now in part B, it's given that the CF distance is 0.4 meters. We have to find out the value of theta. So for that, let me just draw an extra separate diagram only for that. Let's call this point as F. Let's call this point as C. So this distance becomes 0.4. This is 0.4. And now we have to find out the value of the theta that is over here. So let me draw a dotted line with a different color maybe. And now this theta is something that we have to figure out. Now, if you remember from our previous questions, let's say that this 0.4 needs to be rotated in the vertical direction. Okay. So if I'm drawing an axis over here, I need to rotate this kind of 0.4 meters on this y-axis. If I'm trying to rotate this away from this marked angle, this becomes 0.4 sine of that angle, right? And this height is going to be similar to the height of from C to F basically. So this height and this height are same. So this is 0.4 sine theta. I can write this as 0.4 sine theta. So now we know what's the height between C and F. We know what's the velocity at F, but we don't know the velocity of the particle at point C after the collision. Because from C to F, it's traveling as a combined particle R and Q. So let's again use the conservation of momentum to find out the velocity of the particle once it starts its journey on that inclined plane. So again, we are using that same format. Initial momentum is equals to the final momentum. For particle Q, it was having mass of 0.1 kg, traveling with 10 meter per second. And the other thing is at rest, the mass of that particle is given to us as 0.4 kgs. But yeah, it's at rest. So this whole term is zero. It's equal to the final momentum. When it's combined together, the masses are going to be simply added together. So 0.4 plus 0.1 is 0.5. And now the velocity that we don't know, let's just call it V. That's something that we are trying to figure out. And now if you solve this in your calci, the value of that velocity of, you can call it, let's say QR if you want, right? QR. It's going to come out as 2 meter per second. So now with that velocity, it's going to start its journey. So we know what's the initial velocity. The final velocity is 0. We also know the height. So surely we can now go ahead and implement which rule? Work energy rule or work energy theorem. So again, we can say that delta W is equals to delta KE plus delta P. Again, there is no force because of which it's moving upwards. It's only because of the inertia that it's going up, because it's already having a speed of 2. So until that 2 becomes 0, it will move up because of that inertia. It's not having any kind of driving force because of which it's moving upwards. Also, again, there is no friction. So overall delta W stays 0. Then delta KE, the change in kinetic energy. So half, the combined mass is 0.5. Then final square minus initial square. So final square is 0. Initial square was 2. I mean, initial speed was 2. And that's what we figured out. Over here, it's 2 meter per second. So this is the change in kinetic energy. Now the change in potential energy. mgh, combined mass is 0.5. The value of g is 10. What is the final height? The final height, let's say that we are trying to find uh, this height till f. So it's 0.4 sine theta, right? So 0.4 sine theta. And once it's reaching that point F, what's the initial? Initially was at C, right? We considered that this is the reference point ground. So that's the height of 0. Now, if you will go ahead and solve this equation, you will get that sine theta is coming out to be half. Basically, the value of theta is something that I'll write directly. You can solve this the way you want. The theta value will come out to be 30 degrees. So that's the answer of part B. Okay, we got an idea that okay, after the collision at point B, Q is coming at the back. Okay, P is coming from the back as well with the velocity of 4 meter per second, as we had seen in the part A. But Q is already traveling ahead with the higher speed, and it is already colliding with Q. I mean R. Q is colliding with R. Then together it's getting combined after the collision, and it's traveling till F, and then it again comes back down till C. That's something like, it comes down to C and it can move in the leftward direction as well. But yeah, this is the kind of information that we have understood from part B of question 7. Let's see if we're having question C, or else yes, we are done with this whole. Oh yeah, there is question C. All right. So now let me get rid of everything else. So over here, the distance, we have to find the distance from B at which P collides with the combined particle QR. So obviously, as I mentioned, as P is going towards the right, this QR is going to come back down, pass from C, and maybe somewhere over here it will collide. So we have to find the distance that P is going to travel when this kind of objects will collide together. Okay. So for this, let's see what can we do. Let's think about it. So Q is already moving ahead, and we have enough data about Q and the combination of QR. What about if we go ahead and find what is the time elapsed at least till the point where Q started his journey, then Q and R collides over here, it goes to F, then again comes back down to point C. What's the time elapsed till here? We'll get some kind of time. So now for that time, we'll figure out what is the distance that P has traveled. Has P traveled the whole 7 meters, or has it gone beyond 7 meters? So all that kind of information we'll be able to figure out from this. So let's first of all go ahead, as I mentioned, and find out what's the time taken. First of all, for Q to travel from B to C. From B to C. All right. So for that, we know that first of all, there is no acceleration because it's moving with the constant speed. So we can implement the formula that speed is equals to distance over time. So from here, if you want to find out the time, the distance that Q has traveled is 7 meters. And with what speed? The speed is 10 meter per second. Now that's nothing but 0.7 seconds. So it took particle Q to travel from B to C in 0.7 seconds. Now what about C to F? That's something that we have to figure out. So from C to F. And don't forget, we are solving this for Q. For Q and QR basically, right? Because from C to F, QR journey is going to start. So if I want, I can just write it in a separate way so that you guys are not confused. This is for Q. This is for Q plus R together as a particle. Right? So from C to F, what's the time that it took? Now we know that the value over here for the distance is 0.4, right? That 0.4 meter is given. The speed at which it starts this plane is 2. And over here, we know that the speed at point F will be 0. So now the formula that comes into my mind that does not involve acceleration is S is equals to U plus V divided by 2 multiplied by time. So over here, if you implement this, the distance that it's traveling is 0.4. The initial speed is 2. The final speed is at the maximum height, the speed is 0. And then divided by the 2 because of the formula. And then there is a time. So now if you solve this, you will get the value of time. You will be getting the value of time as actually 0.4 equal to, right? There is an equal to sign over here. So now if you solve this, it will be 0.4 seconds. So now if C to F is 0.4 seconds, automatically it means that when it will come down from F to C, it will be 0.4 seconds. So let's if I'm just writing the statement that from F to C, obviously the time it's going to take is 0.4 seconds. The same time that it took to go up will be the same time that it will take to come down. So again, this is for Q plus R, right? Now, what is the total time? If you add 0.4 with 0.4 and 0.7, it comes out to be 1.5 seconds. So therefore, total time for above journey is equals to 0.4 plus 0.4 plus 0.7, and that, as I mentioned, is 1.5 seconds. Now we have to figure out what is the amount of journey that P has traveled in this point, like during this time. Has it gone beyond 7 meters, or is it still not traveled that 7 meters? What's the condition? Let's check. So now for P. Okay, so for P, we are checking if it has traveled this BC or not in a proper way. So now it is traveling still on BC. Let's assume that it's traveling on BC. The speed is going to stay as it is, right? And the time is 1.5. And we know that the speed is equal to distance over time. So if you are going to calculate the distance, it's going to be speed into time. So distance is equals to speed into time. And 4 times 1.5, if you calculate, it comes out to be 6 meters, right? So that's 6 meters. So it means that P is somewhere over here. Let's say this is 6 meters. So when Q and R together is over here, I'll just draw this new diagram so that the confusions are not there, right? Okay, so over here, if I just get rid of this and get rid of this as well. Oops, I guess I deleted the upward part by mistake. Anyways, it's back. I'll delete everything properly. Yeah, so now over here, this is 7 meters. Let's say that this is 6 meters. And this is the last 1 meter. And this is point C, where Q and R together are there, Q plus R. Over here, there is P. So there is still a room of collision, right? It still has not collided. So what will be the distance that P is going to travel in that direction? What's the distance that QR is going to travel in that direction before they collide somewhere over here, let's say. So for that, we'll have to figure out how we can do this. So for that, I'll just clear all the stuff. So it's not getting deleted for some reason. I don't know why. What's happening, bro? Yeah, it got deleted. All right, so now let's figure that out. So we are for P. Okay, let's start for P. So it has already traveled 6 meters, and additionally, it's going to travel some more distance before it collides with Q and R. So that additional distance that I'm going to add on top of 6 is going to be, we know that distance is equal to speed into time, right? The speed is 4 and the time we don't know when it will collide, right? From that point of time. Already 1.5 seconds is elapsed. After that, this is the extra additional type on top of that. For QR, it's traveling back from 7 meters, right? So I don't even need to write this 7 like 6 m. I can just write 6. And over here, I can start from 7, but now I'm traveling in the opposite direction. So I'll just write minus and the extra distance that it's traveling. So the speed at that point was 2 meters per second, right? So 2t. At point C, the speed of QR was c. If it's traveling upwards or downwards, the speed will remain the same if there are no external forces acting on that whole object, right, throughout the motion, which is the condition in this case. And therefore, at point C, the speed of QR will remain 2. But now, because it's traveling the opposite direction, it will have a negative sign, and speed is 2. The time of the collision, that in both the cases, it could be same, right? P will take the same time as Q and R to collide, and therefore this T will be same. So now when this collision will happen, both of them should have traveled some distance, and when they collide, the distance will be same. So what we can say is, therefore 6 plus 4t will be equal to 7 minus 2t. And now if you solve for t over here, so it will be 6t is equals to 1. This implies that the value of t is 1 by 6 seconds. And now because we have to find the total distance from B, this distance that we are traveling, like measuring, is with respect to B, okay? Distance or distances with respect to point B. Okay, both of these distances are with respect to point B. 6 plus additional distance, and over here, the whole 7, from that 7, we are taking away some distance so that it means that we are coming closer and closer towards point B. All right, so anyway, we have got the value of t at which this two distance will be equal, at which they will collide basically. And now the final step. This implements that the distance of P from B is equal to 6 plus 4 multiplied by 1 by 6. And if you put these details in your calci, the result that will come out is going to be 6 2/3. 6 2/3. 6 2/3 meter. So yeah, that's the final answer of part C. And yeah, that's it for this whole question. We are done with question 7. And I hope that you have enjoyed this whole February-March 2023 session for paper 4 as well. So yeah, now I'll see you in some other paper, and all the best for your upcoming examinations.